So hello and good day. This is another day for us to solve a problem in Leetcode. So the one we are going to solve on is the reverse bits. So what it wants to do here is we are going to reverse the bits of a given 32 bits unsigned integer. So any number, would you be translated into bits of zeros and ones, and then you're going to flip it into the reverse of the number. So for example, the input here is a bunch of zeros and ones, and I suppose this has the decimal equivalent. What it wants it to be, there are 32 bits in this binary number, the 32 bits of the binary number. You're going to reverse it. So this zero comes over here, and this one comes over. So it's like a flip of the number. So the reversal of that number is 964176192 in decimal, which in binary is this. For explanation, you see what they said. The input binary string represents the unsigned integer. This is the decimal of it, decimal version of it. So it returns this number, which is its binary representation, the reverse of it. The same thing also happens here. If you watch very well, you have at the end of this number, you have 10. But you see at the beginning of the output, it begins with 10, the reverse of it. So that's what we want to achieve. The constraint is that the input must be a binary string, like I said, in zeros and ones of length 32. So how are we going to achieve this? Let's see how we are going to like run. Um, so for example, let me just take this and use it as an input and output for like an experimentation before I now run it into um, the space, the code space for Leetcode. So we come over here. This is our VS code where we can experiment on that. So so we'll run we write the code. And I think maybe we just find the binary equivalent of this. This now, what number is this? The decimal equivalent of it. So you have integer. Let us put it in strings, and then is in two. It will give the integer equivalent of this binary number. So at least we are going to put this number into the function we're going to write. But let us be writing the function reverse bits, then takes in the number. So this we take in the final value we are getting from our function. And then since we are told it is 32 bits, so we are going to have the 32 bits of the numbers of the zeros and ones. So we have for I in the range of 32. So we are going to check the bits that are in the number. So for example, if you see in this number now, you see that there are ones here and then there are zeros. So we are going to find not only this one, but also the position of this one. So this is the integer equivalent of this number. So the not only this one, but also its position. And the function we are going to, what you're going to use in getting this should be the AND operator. So if you have maybe number like the 101 now, and we have like the number one at this point, yes, at this point now, and we have one here. So if you use this operator, there's an operator that we use there, so to be able to push the bits. So once it comes to this one, if you use and one will give us one. So it tells us that there is a bit in this position. But if you move this one to this position, if you move this one to this position, this position of 0 now. If you have 1 here, if you have 1 here, for example, if you have 1 here, 1 and 0 will give you 1 and 0 will give you 0. So the output of this one will be 0, which means that there is no bit here. So, but if you also bring 1 here, 1 and 1 will give us 1. So the operator we are going to use here is the AND operator, and then we use this operator here to be able to push the bits in the, should I call it, in the left direction. So if our number and then and the AND operator, we are going to push 1 in the direction of the position of our I. If it satisfies this condition, then we are going to add this number into our rest. So it's going to be rest, and all. We have our operator. We have 1 will now be pushed in the direction of 32 minus 1, which is 31. And it's going to be 31 minus I, because it's going to be 31 minus I. So it performs the operation of the reversing of it. So if you have here now, if this thing satisfies this condition, let's suppose that there is 1 here, 0 here, shall actually, but if you suppose that there is 1 here now, and if you place 1 under this, 1 and this, yes, 1 under this will give you 1, and 1 will give you 1, right? Because our 1 is on the position of 0. So you're going to put this 1 at this position. And this position is actually the 31st position. So you're going to move your 1 31 times, because this is actually 31 minus 0, which is 31. So you're going to move 1 to 31. If you come here now, that is 0 now, it does not occur here. You're not going to move it. When you come here, it's going to be 29. So you're going to move it 31 minus 2, which is 29. So you bring it over to this position. You see? So it gives a mirror effect, moving it away from this position to the equivalent position as the case would be. So that is how it reverses the function. So here now, after running this now, or you can even write this in a short form, in a short format. You can just write it this way, and then the word. Then we're going to return our what? Our rest. Remember, this name was 0 actually. So give us this number. Yes, to return rest now. So I think it will work out now. So this is the reverse bits. So if you write this reverse bits now, I'm putting this number here now, this integer here now. Watch very well. You put this integer here, but it is going to give us this output. You could remember this was the output we got. So it's going to give us, let me put it here above here so that you can easily see it here. Put it above here. It's going to give us this number if this thing works out well. So let us run it and see. Exactly, 964176192. So that's how you perform the solution of this, the reversing of the bits of a 32-bit unsigned integer. So we just lift up this code, then bring it to our Leetcode. So this should be our Leetcode. Yeah, this should be our Leetcode. So we put it here. So our rest is 0, our then the for loop, and then the conditional statement, then the operation, and it's going to return this. Let's see if it's going to work out. So we run it. It satisfies the condition perfectly satisfies the condition, and then we'll submit it. So it works out well. So this is for um, reversing of the bits of a given 32 bits unsigned integer.